Hello everyone, and welcome back to the Fluctus channel. The U.S. Air Force has over 5,200 active aircraft ranging in age, from just delivered to 60 years old. The cost of operating and supporting the country's combat air fleet is mammoth, with nearly $50 billion per year spent on maintenance, spare parts, engineering support, and personnel. In today's feature, let us explore the mesmerizing machines and facilities used by the U.S. Airmen in repair and maintenance. Safe landing and takeoff requires tires to be maintained to the most exacting standards. They undergo regular inspection, repair, and maintenance, and must be changed after a certain amount of landings, depending on the type. The tire-changing process of a military cargo airplane, such as the C-17 Globemaster, is a complex, multi-step procedure. It takes about 5 people working together for 2 days to break and build up all 14 tires. The airmen first secure the new tire to the tire dolly used to carry the 390 pounds wheel. The dolly is used in both removal and installation of the wheels, which are then accurately positioned into the bearing of the landing gear and fixed tight with wrenches. The Aircraft Parts Store at Ellsworth Air Force Base, California, is the place that takes care of all components and spare parts. Its primary goal is to ensure the aircraft is fully operational and safe to fly at all times. This busy shop specializes in metalwork, manufacturing parts for aircraft, including the main landing gear support, bell cranks, filler, brackets, and many others. Other daily responsibilities include verification, inventory control, checking, and moving supplies in the warehouse. Aircraft Metals Technology Shop in Alaska is responsible for the design, fabrication, and welding of precision tools for aerospace weapon systems and support equipment. This includes heat treatment of tools and components. Some of their tasks include working with conventional and computer numeric control machines, determining machine requirements, calculations, and settings. The final goal is to ensure the completed components are serviceable and meet required specifications, delivering solutions to the U.S. Air Force. Another significant division of the U.S. Air Force Maintenance Group is the Oklahoma City Air Logistics Complex, which employs over 10,000 military and civilian personnel with 98 different job skills. The complex utilizes 65 buildings on an 8.4 million square feet of industrial floor space in support of its mission to produce, repair, and test combat-ready weapons. The complex performs programmed depot maintenance and modifications on several U.S. Air Force aircraft. While the above facilities play a critical role in timely supply and maintenance of the air fleet, the Air Force Test Center is strategic in testing and evaluating equipment in the development phase. Headquartered at Edwards Air Force Base, it carries out developmental tests and evaluations of air, space, and cyber weapon and flight systems to provide decision makers with timely, accurate, and factual data. In 2017, the center created the Near Field Velocity Measurement System, which can monitor the local air velocity around test subjects for wind tunnels placed in expansive wind tunnel facilities, such as the Propulsion Wind Tunnel. The system examines light reflected by tiny mineral oil droplets that are introduced into the circulating air. By assuming that the air velocity is the same as the particle velocity, the light is sent to a detecting system, which analyzes it to calculate the air velocity. The output data provides the Air Force with detailed information to be able to mitigate future risks that may be very expensive to fix later. The Propulsion Wind Tunnel, devoted to aerodynamic and propulsion integration testing of large-scale aircraft models, holds 3 wind tunnels, including the 16-foot transonic, 16-foot supersonic, and the aerodynamic 4-foot transonic. The Arnold Engineering Development Center, located in 8 states, consists of a space systems test facility conducting test and evaluation of space and missile weapon systems. The facility was established to aid the development of resilient space components, materials, subsystems, and systems for the next generation of space and missile capabilities. It operates more than 68 aerodynamic and propulsion wind tunnels, rocket and turbine engine test cells, environmental chambers, arc heaters, ballistic ranges, sled tracks, centrifuges, and other specialized units. Facilities can simulate flight conditions from sea level to 300 miles and from subsonic velocities to Mach 20. This strategic national resource has contributed to the development of practically every one of the country's top priority aerospace programs, including the Space Shuttle, Space Station, and Projects Mercury, Gemini, and Apollo. When it comes to testing and maintaining the engines of an aircraft, the U.S. Air Force avails the Hush House, an enclosed, noise-suppressed facility used for testing aircraft systems, including propulsion, mechanics, electronics, pneumatics, and the like.
Yeah, they're usually stripped. But
Additionally, the engine back shops keep the engine serviceable and mission-ready. The maintenance process involves receiving engines that need repair, breaking them down, inspecting its various components, repairing them, and building them back up. The engines are tested for their airworthiness before being released back into service. The facility works, in particular, on improving the engine of the A-10 Thunderbolt, constantly introducing measures to make the process more efficient. The A-10 Thunderbolt II is the first aircraft by the U.S. Air Force, specially designed for close air support of ground forces. Following in the footsteps of the legendary P-47 Thunderbolt, the aircraft was developed by Fairchild Republic Company, which is now a part of Northrop Grumman Corporation. The simple, effective, and survivable characteristics of the jet, fitted with two General Electric TF-34 GE 100 turbofan engines, make it a flying beast. The 53-foot-long fighter has a wingspan of 57 feet and provides exceptional mobility at low airspeeds and altitudes, boasting an excellent platform for delivering weapons with high accuracy. Thunderbolt is able to perform austere landings and can loiter around conflict sites for extended periods of time. Its special design features a titanium bathtub that protects the pilot from injury, as well as dually redundant flight control systems, allowing the jet to fly out of enemy range despite severe damage, such as, for example, complete loss of hydraulic capability. These features have been effectively utilized in both the Desert Storm conflict in the 90s and in the more recent Enduring Freedom, Iraqi Freedom, and Global War on Terror engagements. Apart from the few dedicated facilities, the A-10 may be maintained and operated from bases close to the action. Its engines, main landing gear, and vertical stabilizers are only a few of the sections of the aircraft that may be switched between the left and right sides. It is due to these effective and productive maintenance, repair, and testing facilities that make the U.S. Air Force soar to the skies while on missions. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.